We're going to start 10.1. And 10.1 you're going to find to be mostly definitional. We are starting in the circles chapter, and the majority of this first section is just making sure you can identify. This is identifying special segments and lines. We're also going to talk about drawing and identifying common tangents and using properties of tangents in this particular video. So the first thing, let's just kind of review some vocabulary. Most of us are very familiar with this, but just in case, this is a circle. If a line goes clear across through the center, this is called my diameter. If we go from the center to the outer line, no matter how it's put, this is going to be my radius. A line that cuts across but not through the center is called a chord. And of course, the point in the middle is called the center. So let's add to our vocabulary. A secant is a line that intersects a circle in 2 points. So this is an actual line. So let's draw another circle here, and let's add to our definition. So here's the center of the circle. A secant is a line that cuts through but not through the middle. Okay, so this is called a secant. Remember, the difference between it and a chord is that it is a line that cuts, not a line segment. A tangent is a line in the plane of a circle that intersects the circle in exactly 1 point. So a point of tangent basically is a line on the outside, and it touches it right here at 1 point. Does it touch the line? It doesn't touch it anywhere else. So when we talk about a point of tangency, that is the point on the line that touches the circle. It doesn't cross through the circle, it just touches the circle. A tangent ray also is the same thing, it's just you're going to start here and describe it from that point on. Okay, let's talk about coplanar circles and common tangents. So for the definitions in that, basically in a plane, 2 circles can intersect in 2 points, 1 point or no points. So coplanar circles that intersect in 1 point are called tangent circles. So an example of a tangent circle is like you have a circle and then you have another circle on the inside, but they only connect by touching. They don't cross over, they just touch. And usually there's a line that involves in that, but basically 2 circles are touching a line of tangency. You can also have it look like this, a circle here and a bigger circle here. Sorry about the not great circles, and a line that cuts between them, but they all touch at 1 point. So those are 2 different examples of a tangent circles of 1 point intersection. Now, 2 points of intersection. This is considered basically coplanars that have common centers are called the concenter circles. So like this, I don't touch, but I'm a circle within a circle, and they both have the same center point. So a common tangent is a line or a line segment that 2 coplanar circles is called a common tangent. So basically a common is going to be they both make a circle and they attach at 2 spots. Once again, sorry about the not so great circles, but I think you get the gist of what the vocabulary is trying to talk about here. Now, so when we look into our notes, the first thing we have here are some different planes. So let me move some things out of the way here so we can slide our paper up. And what we're going to do is look at the first 6. So basically, I have a circle here with a line that cuts through here, and a line that goes across there. This is B. We have a line that goes across here, and a line that goes across like this. That's A, this is E, this is D, and this is F. So these are all the different points that we have for this circle. Now, the very first one says, name two radii. So we have two, but actually there's three radii that we could, in fact, name. And these two connect here. So I could say for number one that I have AB, I could say AF, or I could say AD. Any of those three could be listed as two of them. You didn't need all three, but there's three possibilities. Number two talks about a chord. Well, a chord is basically a section. So there are two different ones you can do here. You could tell me CE or EC. And then they also include the diameter as a chord, because technically a chord is a line that goes across the circle. We also kind of put in there that it wasn't the diameter, but the book still defines it as that. So I will put it in there and accept the answer. But normally a chord is not always the diameter. It is usually the line that's not the diameter that they usually ask for when you go through this. Number three is the diameter, which is DF. We know that one. Number four, name a secant. Now, a secant is the line that cuts through the circle. In other words, it has 2 points of intersection. So that is going to be DE, and you're going to make it with the line symbol above it. Name a tangent. Well, a tangent is a line that cuts through, and we didn't have two dots put on that one. So for this particular one, you're just going to say line through point B. That's all you're going to tell me there. And then number six, our last one, says name a point of tangency. Well, the point of tangency is point B, because that's where the circle and the line can join, in this case, without the line cutting through it. All right. Now, number seven, it says, tell how many common tangents the circles have and draw them. Well, in this case, I have two circles that cut each other, and they look like this. I have a circle here. There's my dot. This one actually, its midpoint is that one. It has a dot. So basically, the two circles here. A tangent is here and here. So I want them so that they both touch, but I can do the bottom and I can do the top. So this one would have two common tangents. In other words, I cut two different places, and I can have 2 points here and 2 points below that cross. So 2 is the magic number for this one. Tell whether each common tangent identified in exercise 7 is an internal or external. Well, this one is going to be an external, because we have the lines drawn on the outside. So for number 7 answer, we have this, but for number 8 answer, we're going to say that is an external crossing. Now, the last couple that we have here, let's look at number 9 and number 10. Now, number 9 is getting into Pythagorean theorem. So it says find BD. Well, BD makes a right-angled triangle. So there's the right angle. This here is A. This is 10. This is B. This is X. This is D. And this is 5.5. So I'm going to use Pythagorean theorem. So 10 squared equals 5.5 squared plus X squared. So this is going to be 100 equals 30.25 plus X squared. So when I subtract this across, this is going to give me 69.75 equals X squared, which is going to give me 8.4 for X. So X is 8.4. So for number 10, it's the same concept. All right. So I'm going to use the same method for number 10. The only difference is, well, let's go ahead and do this. So when we actually get this difference for number 9, we're going to start here for number 10. So number 10 is taking this answer here, and we know that the length for this is going to be used as a Pythagorean theorem, basically again. So we're going to take BC is the same length as BD. Okay, so we use Pythagorean theorem for 9. To get what our BC is, it is the same distance because the radii would be the same distance to AC. Therefore, it would be the same right triangle just on the side there. So let's find out find the x value to the nearest tenth is what it's asking for here. So if I have 4x plus 6 is what BC is, what is my x value? I'm going to just set it equal here. Now what I'm going to do is this was 8.35. So I'm going to go ahead and put that out to the 8.35. It is the same as 8.4, but that's the calculator gave me, and it kind of gives me a little better answer. So I'm going to subtract 6 across, which gives me 2.35, and then divide by 4. So x equals 0.6. So if x is 0.6, then they will give me the same length. BD and BC would be my same lengths. Okay, so that's the end of 10.1 lesson.